Okay, welcome to Programming Rainbow. In this video, we will be continuing on the series of Don't Eat the Yellow Snow in C++ and SDL2. This video is not going to be actually anything on C++ or the game. It's going to be on the Makefile that we're using to compile the C++. So if you want to follow along with this video, you can go to github.com, Programming Rainbow, and this one will be called Yellow Snow tech cpp tech SDL2, and you can git clone that repository, move inside the directory, and you can. So we have kind of seen all the code, and we've been using a Makefile throughout this whole series to build, to do the make, run, the all this kind of stuff. Well, let's see if we can just run it. I'm not sure if it's built. Yeah, there it goes. And yeah, that's the game. So what about this Makefile? So the Makefile is actually down here. It's actually called Makefile, capital M, make, and the only thing is capital M. And basically, it's a bunch of rules on how to do something. It's variables and commands and stuff. So I kind of just want to go through and explain this whole thing because this is set up very generically. I drop this into any of my projects, and the C version of this is almost the exact same as well. I do have like 3 more other flags for the strict version. I have like 3 more here that are for C, not for C++. And I'm using G++ instead of GCC. And the files are called CPP instead of C. But other than that, the file is the same for my C projects and my C++. And to show you that, let's go over here to a C project. And let's build this one. Well, it's already been built, so we can just run it. And this is Minesweeper, so this is nothing like what we've just built. And this is in C. This is not C++, although I have a C++ version of it that's the exact same. Let's kind of see what it looks like. And we have all these different themes, all the different and we have different sizes, and we have different difficulties where we can have different amounts and so on and so forth. So that's pretty cool. But this file is almost the exact same. If we look at W shadow and we start looking at this missing prototype, strict prototype, and old style definition, these don't apply to C++. So they're not in this C++ version. So the difference between these two, you'll notice, is happening right down here, where there is a couple more. But most of it's the same. You're going to throw your name up here. This is the build directory that we want to use. It's just .build. That's just whatever I called it. And everything's the same, but it's GCC. This one here, we're targeting C11, whereas this one we're targeting C++ 20. So these two are different. When we start talking about the C files, they're CPP files instead, over here as well in a couple places. And that's really it. There is not much difference. So I'm just showing you that it's kind of generic, and you can use it for C or C++ with just minor variations, and it's just meant to do the task. Okay, so let's look at the C++ version. These are variables over here. These are just like variable definitions or declarations, or however you want to call it. We are setting with the equals. So this variable called target is Minesweeper. Sorry, I'm in C, not C++. There we go. This yellow snow is this target variable. Okay. So we know what variables are and all that. So just understand that this is just a variable that I'm defining, and it's set to the string yellow snow. And build directory, this is just something else that I'm creating. I'm just saying, hey, I want a variable called build directory. So it can be changed up here right at the top if I ever want to change it to something else. But what's going to happen is whenever I compile this, see right here, it's going to build in this build directory. And it's also going to build this binary file right here. So this build directory is created, all the stuff inside of it, and this. So when I clean, it's going to delete this binary and it's going to delete this build directory. So that's pretty easy. So I'm saying my target, this will be whatever the name of the binary that you want to create. So in the other one, it was Minesweeper. And this build directory. Now, this one right here, I have a question mark and an equals. This will set this source directory variable to src if it's not already set. So what this allows me to do, so if I just type make, it's going to set it to, it's going to set source directory to source. But if I were to do something like this, if I already had src underscore dir already set to something, then it's going to use what it's already set to. It's not going to set it to this. So when I go src dir and I say equals, and I could say instead of targeting the source directory, I'm going to target video 1. I could do video 01 and then do make. So now when make gets run, it's going to say, oh, this has been set already. I already know the answer to what this variable source directory is. It's video 1. So when it comes down to here, it's not going to set this. So this is a way for you to override. So I do it in a couple places, like CXX I use for C++, and CC I use for C files. But this CXX, you may want to override this because maybe you don't want to use G++. Maybe you want to use Clang, Clang++, or something else. You want to use some kind of different compiler. So you could just easily put that here. I could just say, I could just say CXX equals Clang++, and now I'm going to compile with Clang++. Okay, so that's what the question mark equals does. That basically it's setting it if it hasn't already if it's not already set. So I'm not going to explain these, what all these compiler flags are doing. You can look these up kind of on your own. I really want to talk about the Makefile here. So, but this is setting the target that G++ is going to target is C++20. And what I'm doing here is I basically want different flags to be used, different compiler flags, but I want them in different situations. So let me just close this. So what I'm doing is I'm kind of setting up a couple different things. Basically, I always want this. So this is my kind of compiler flags base. No matter what thing I'm doing, I always want to be setting C++20. Unless you're targeting another thing and you change this, but I'm in this project, no matter how I'm compiling it, whether I'm doing a debug or release or just a normal compile, I'm always using this. So I'm calling this my base flags. And then I have other flags. I have strict flags. I have release flags. Okay, so what I'm going to do is I'm going to be using these in different situations. And I'm doing the same thing with strict flags, release flags, debug flags. Then I have my link library, and my base one is nothing. You might set these for other things, but I have a base one, I have a release one, and a debug one. I guess I'll jump around a little bit. The reason why I'm doing this like this is because by default, if I just say make, it builds it, it's going to use this one right here, the base one. So if we come down here, it's saying if this hasn't been set, if we haven't override it, just set it to the base one and set the libs to the base one, which is actually nothing. So when it comes down here and it starts compiling things right here, it's just using these flags. And when it links, when it builds the final, I'm going to swing back around to these. I'm not explaining everything, but when it needs to use this variable right here, it's going to be using my base ones. But in other situations, I want it to be more strict. When I'm doing the release or the debug build, I actually want to use the strict flag. These strict flags tell GCC, or if you're using Clang, they tell it to, I'm basically turning on a whole bunch of warnings and also making my warnings as errors. So I'm being very strict. So I'm making the build fail if there's any kind of, if the compiler doesn't like anything that I'm doing, it's going to warn me about it and then fail. But I relax this a little bit on just a base. If people just run make, it's not going to do any of this stuff. It's just going to do the base thing. But if I'm doing a release build or a debug build, it's going to do this one and then add this to it. So this is just basically a string, and this is another string being added to it. And if I were to do a release build, it would do this one here and add this to it. Oh, sorry, it would do this, add this to it, and then add this to it as well for my release. if I was doing debug, it would do the base, it would do the strict, and then it would add the debug to it, not the release, but the debug. So the release one, it has things like compiler optimizations, things like that. The debug is leaving in the debugging symbols, and it's not optimizing for anything. So I'm not really going to explain all this too much, but I'm just explaining my thought process of what's going on here. I have the base thing that I need to happen no matter what, but then in special circumstances, I want to make it more strict. I always kind of want it to be strict, but other people will be using this, so that's why I made the base one not strict. But the strict one is used for on both of these. So down here, when we look at these, I'm saying base flags, strict flags, and release flags. Same here, base flags, strict flags, and debug flags. So they're just being added together. So this is just a variable. It's just setting it. This backslash right here is just a line break because this line needs to keep going and going and going. And this just allows me to continue on to the next line. So that's what this backtick is here. So these are just compiler flags that you would type in. You would say G++ and you would say minus std equals C++ 20. If you're typing it in the command line. But this allows me to put in a whole bunch of stuff and to group them the way I want them grouped. And I put them once here, even if I didn't set them, because there may be other projects where I do need to set them. So down here, something else is happening. I want to deal with whatever my source directory is. I want to get all my C++ files that are in the source directory. And I'm going to call those sources. So this sources is going to be this. So let's, I'm going to borrow this guy right here. And I'm going to print it out for you so you can see what it is. So this info right here, I'm just kind of skipping ahead again, but this info is a function. It's a Makefile function. And it's going to print out this just directly OS. This is just like printing it out. And then it's going to print out whatever this expands to. And I actually don't want this. I want this right here. So if I put srcs sources, this $sign and the parentheses is going to take this variable and expand it out to whatever it is, which will be this. So that's saying whatever this variable is, but it's not called OS, so src. This is just for printing out purposes. So this right here is going to, whatever this function returns. So that's what it's kind of, I don't want to say evaluating. The $sign in parentheses either returns the value of a variable or the value of a function. So this is returning directly the value. So this is going to print out directly to the terminal. What's happening here is I said this is a make function call right here. This make function call takes this and prints it out as a string. Right here, this is a make function call as well. And it's in parentheses and a $sign. So this src is going to be whatever this $sign is going to be, whatever this function returns. And this function call is a wild card. So it's going to take this again as a variable that is going to, get the answer to it, which is up here. Whatever this src is, assuming it hasn't been overridden. Assuming it's not overwritten, it's this small case src, which is this right here. So it's going to be that. And then we have this asterisk.cpp. So it's going to look in here for all the CPP files. But it doesn't understand this asterisk by itself. It needs this function wildcard. So this wildcard says, hey, I'm going to be making a list. I'm going to output kind of a list of strings. It's going to be flake. It's going to be FPS. It's going to be game. And we're going to print this out. So I'm going to print this right on the screen and we're going to see the output of this. So let's save this real quick. Now just do a make clean. It doesn't matter what I do. I just want the Makefile to run. Okay, so see this sources is right here. This is printing out right here exactly what I put. I could have put Bob there. It doesn't matter. But now we see this src flake.cpp, all these are all the files that are in here, not the H files, just the CPP ones. So this wildcard function allows us to make a list with this kind of wildcard asterisk symbol. Okay. And this is how you can output something like that. So basically, this variable, if it was put into a $ parentheses somewhere, is going to see this. This is what it's going to actually get when it's kind of evaluated or replaced. Okay, so let's do it again. Down here, this becomes a little bit more complicated. So this, I just need a list of all the source files. You know, like if you were compiling GCC, you would have to type in every source file separately. So on this one, it's a little bit different. So let's start with the innermost thing, what's happening here. So this is the $ in parentheses and then sources. So this right here is this list now, because we've already done it right here. So when this $ is replacing this src with whatever it evaluates to, which is this. So that's what's right here. But this colon right here, like a pattern matching replacement. I'm sure I'm using the wrong term here, but it's for replacing patterns. So this one says, hey, this whole list right here that we have, take each one of the .cpps and make it .o. Okay? So that's what's going to happen here. With just this is evaluated right here, I'm going to get a list that looks exactly like this, except they're all going to be .os. Now this function right here is not directory. So it's going to instead now, this is kind of being evaluated, and then this is being evaluated. So this is going to give us that same list, but without the src forward. It's just going to be the name. So it'll be flake.o. Okay. But then we're running this function on it. And we're saying, hey, take that entire list. This function says, hey, prepend this right here, build directory, to that entire list. So the entire list we have is just the names of everything .o, and we're going to prepend whatever this build directory is, which is .build, to that entire list. So let's see the output of this and see if that's exactly what happens. So I'm going to change this to objs objects. These are going to be all the object files that are built. And I want the actual output of objs. Okay, so I'm just going to do the make clean again. Now we see it's build.flake.o. So basically it took each of these names and it changed them to the O version, but it also took away the src and put the .build on it. Okay. So this is basically all the target build objects I want to build. I know what all my sources are, and now I know all the target build objects. The reason why is I want them to build one at a time. I don't want, if you're just typing this into the command line, you may, well, let's see here. Let's see what we get with this. I need the directory. So this is not even showing me anything. It's just going to try to build the entire thing, which might take 20, 30 seconds. And then it's going to give me a binary that I called test. And there it is. There's the binary called test. So I'm not actually doing it that way. I'm building them one at a time and letting them output object files. So we could say like, and it should be, yeah, there it is. The flake object file was built right here. So kind of I'm building them one at a time like that. And the reason why is because I have all these different files to build. And what if I just changed one thing here? I don't want to build the entire thing again. I only want to build the object file for the one that I changed. And then I can build the final binary from all those object files and link them at the end, which I probably didn't need the linking information here. Let me just check it out. I don't think I needed this at all because I'm not linking it. Yeah, so if we did this on all of them, Flake, FPS, oh, can I just do that? Will that work? Yeah, there we go. So if we build them all separately, so we have all these O files, and then we could take all these source. Oh, I'm going to need all those right here. We can call this test2. Now this should use the O files and output a binary called test2. If I actually, and I didn't do it right. Oh, sorry, they're not in that. They're not in source directory. They're actually in the top level directory. Oh, I didn't get all of them in here. Okay, there we go. So I'm explaining this very badly, but anyway, you would. It's kind of like you can do them one at a time, even though I did them all in a batch. You could do them one at a time, and then you could whichever one changed, you can tell it to just recompile that one object file, and then you can do the last bit. So there's two steps here. And I did it with a wild card. So it's because I didn't want to type it in one at a time. But you can tell each source file to make the object file, and then you can tell all those object files to create your final binary, and you need to link them as well with the SDL stuff. So I was just kind of showing that, but I'm doing it really badly. I'm sorry about that. So anyway, in the Makefile, we want to do them separately because if you've only changed one thing, you only need to recompile that one thing that you've changed. You don't need to recompile all of them. You don't need to recompile all the object files and then recreate. You can just recompile the one object file that the source has changed on, and then you can relink at the end. You could take all the object files and create your binary again and relink it. So right here, the only difference, I'm just going to walk through all the differences in this file between C and C++. Right here, this one right here is C++ specific. This would be GCC for a C file. Right here, this would be C11 or C99, something like that. C89, C99, C11, not C++. All this stuff would be the same. All this stuff you can use the same. All this is the same. All this is the same. All of this is the same. Right here, this line right here, you would change this CPP to just C. This would be C right here. Right here, this CPP would just be C. So everywhere in this file that you see CPP, you just change it to C, which are basically those two places. All of the rest of this is the same. All of this is the same. All of this is the same. Everything else is the same. This entire file is the same. So all you're doing is finding these two CPPs. You're changing this. You're changing this. And my C version does have a couple more lines right here if we go over to it. So here's the C version. You see GCC is there. STD C++ or C11, sorry, is here. And I have these three added. Those are not in C++. All of this stuff is the same. Right here, we see just the C instead of CPP. And right here, we see the C instead of CPP. And that is everything. So down here, we're looking a little different because this is a Minesweeper, and there is no true type font in Minesweeper that I use, and there is no audio. There's no mixer. So I just didn't add them. So it's just image that I needed. But you could just add those in for a different project if you wanted. So that, yeah, there is no real difference. There's right here, bang, bang, right here, right here. These are the differences between C and C++. And you can just go to my GitHub if you want any of these right here. And if you want to play around with Minesweeper or whatever, it's here. So here's Conway's Game of Life. Oh, that's for Odin. Sorry. There's Odin Yellow Snow. Here is Conway for C. It's going to have the same Makefile that I just showed you. Here's Conway for C++. It's going to have the C++ version of the Makefile. Superclock. It's also going to have that new Makefile. This has the C++ version. Here's Minesweeper. It's the final project. I just haven't recorded it yet. Here's Minesweeper for C. Here's Beginner's Guide to SDL3 and C, SDL3 and C++. Here's beginner guide for Haskell and Yellow Snow for Haskell. So you can play with those. You can see them, but there is no real difference between them. Now, if you go back to the old Yellow Snow, I didn't update it on that one yet because I recorded the video and I don't want to change it vastly from what I recorded the video as, even though I want to change it. I don't want to make it different than what people watched in the video. So I didn't change the old Yellow Snow in C one. Okay, so anyway, so these are variables. These are variables that can be overridden. If they're already set, they won't be set to here. These are more variables. I'm just kind of separating out my flags, base, strict, release, just so I can control which flags are being used. And we've already seen how these flags can be put in, like when I was doing the command line here, this flag here, you would just dump all these flags in, just all of these flags, and it would be just a huge line, which is why you want to use a Makefile. So right here, again, this is a make function specifically. So it's allowing this wildcard to be used right here, and it's creating a list, and we've already seen that. This here is taking that list and changing all the dot. This is kind of like a sed command almost. It's taking all the .cpp and changing them to .0. This is removing the directory name from it. This is actually adding in a different directory name. This append function is taking this directory name with the slash. This is going to be, the dot build directory name right here with the slash and appending it to everything that was there. And this one here is taking all those O files and making a D file for it too. So up here, when, we got rid of the build directory, but let's just do the same thing here and we'll get the output of this. So deps, and since we don't need to change directory name or anything because we want the .d files to also be in the build directory where the O files. So we're just doing this simple pattern matching replacement thing. I'm not sure exactly what it's called. Deps. So this is for dependencies. I'll just do a make clean. And we can see that this dependency list is .build. So it's just basically, this would have been .build /flake.o, and it's just changed it to flake.d. So it's given us a list of dependency files. Okay, and we'll talk about dependency files in a second here. This is untested, so I apologize for anybody on Windows. I don't use Windows, and I haven't set up Windows yet in a VM to really test this, partially because I hate Windows, and the other part is I just haven't had time. But this is me attempting to make this Makefile run in Linux, Mac, and Windows. I haven't tried to use any specific stuff, but right here, these commands get different because I need to make directories. I need to I need to delete files and stuff, and they're done differently in Linux, Mac OS land, and Windows land. So right now, the first thing I want to know, I'm going to get an answer. This is going to return an answer, no or yes, and store it in package config if package config is installed. So, well, up here, this is kind of an equals, if equals. Basically, if this variable right here, which is a Makefile variable, kind of a system variable, something, it's not something I'm setting. If this thing evaluates to Windows NT, and again, I haven't tested this, so I hope this works. I'm not sure if it does. But if this evaluates, it's saying, hey, you're on a Windows system, do this code. If this is not equals, it's going to run this code. So let's just show what's going on right here with this first one. This shell right here and right here, these are, again, a Makefile function. And what it is it's just telling this to be run in a shell. So let's try this. Let's see what this is. I'm just going to copy this and put it in the shell. And it says yes. So what's going on with this? Well, this is just seeing if this command exists. So let's back it up here. See that? And I could also do a which. So which would do the same thing, but let's change it to something wrong, like something that doesn't exist. I put an S at the end of it and I hit enter and it gives me nothing back. And if I do which and I put an S at the end, which it doesn't exist, I get a big, weird, like it says it can't find it anywhere. So let's look at the longer command again. So what is the rest of this doing? So the rest of this is saying, hey, I don't want the output of this at all. So it's taking this, the output of it's being redirected to null, to dev null, which is like a black hole. It's just eating it. It's saying, hey, whatever this is, whatever the output of this is, send it to dev null. But that is only the standard output. That's not the standard error. So in Linux and Unix and Mac OS or whatever, you have standard output and standard error. So this is redirecting standard output to dev null, but error messages like this above here would not be. So let's check that out. Well, I'm going to run that and it gives me nothing, right? And I'm going to change it to something wrong and it gives me nothing, right? But let's do it with which. Okay, I'm going to spell it correctly. I get no output, right? Let's spell it wrong. Oh, sorry, I'm messing up. Okay, let me back up a second here. I should have took this off. So this is sending standard output to dev null, okay? It sends it that way if it's spelled wrong and if it's spelled right. But if I go to the which one, spelled right, nothing happens. What if I spell it wrong? I get that output, okay? So because this is standard error, not standard output. Okay, so what happens here with this extended part right here is this is saying take standard error, which is 2, standard error is 2, and send it to the pointer of 1, which is standard output. So it's saying, hey, let's take all error. I wanted to take the error messages and I want to redirect them to output. And where is standard output going? Well, it's going to dev null. So this thing is basically saying, take both the standard output and the standard error and send it to dev null. I don't want to see it. But what it also does is it tells me, did it succeed or fail? It's giving me an answer. I'm just not seeing it. So when I go here to this full answer right here, this and this code only runs if it's successful. So I use this and a lot, this double ampersands for a logical and or whatever. This is basically saying if your previous command was successful, you can also run the next command. So if this command was successful, even though I saw absolutely no output, then echo yes. And this is the or. The or, if it's not, echo no. So check this out. So this says yes, even though there was no output. But what if we spelled it wrong? I'm spelling it wrong like it doesn't exist on my system kind of deal. And now it says no. And that would actually work for both of them too if I change this to which. That still says no. And if I spell it right, it says yes. So we're storing no or yes in this variable package config. And this is the attempt. Again, I haven't tested this on Windows to do the exact same thing where I guess is the Windows thing. And this is the dev null equivalent in Windows, I guess. I don't know. And again, this is the same idea. It's untested. So we're storing if package config is installed, yes or no. Because we're going to use package config down here. So here is package config. This kind of makes it easier if you don't know where something is installed on your system, but package config maybe can find it. So for C flags, it's telling me, we need to add -I include SDL2, right? And all this other stuff. It's telling me all this stuff I need to make this thing build correctly. These are all in my path in my include anyway. So on my system, GCC doesn't need to know this because it's already in the standard path that it would be in. But if it was in some weird path, package config may be able to figure it out. And there's also the libs one. So we can do this and change this to libs. And this tells me the name of the libs for these packages. For the SDL2 package, it's called -L SDL2 image. Remember, I had to type this in manually. Again, if they were in some weird place or had some different name, sometimes the names don't match up. Like this name and this name are not necessarily the same because this is lowercase. Basically, it's trying to use package config to make it better because if you're on Mac OS, it puts things in weird places. If you're using Brew or something to install, hopefully package config can figure it out. So it's kind of like, do you have package config installed? Because we're going to use it. And Windows, I don't even know, man. Like, you shouldn't use Windows. This is just checking if package config is installed, but it's in two different ways in two different systems. Also, if I'm in Linux, I want to use the F sanitizer. So I'm adding this to my my flags, my debug flags. If I'm using debug, I want to use the sanitizer. Where this, I don't think that you can do this in Windows. So I'm adding it here only in the Linux Unix world, not in the Windows world. Also, to delete stuff, to clean, I need to use the del command /F to get rid of the target, which is an exe, and also the build directory and all the files in it, I guess. This is like the Windows command. Again, not big in Windows. I looked this stuff up at some point. And Linux or Unix or whatever, there is a RM for a Makefile. You can use this RM, which is just going to be normal RM remove. Remove -F for force, the target name, which is yellow snow. That's the binary. And also remove the directory. So that's how you're cleaning up. And I also need to set a make directory in Windows. It's if not exist, this directory make it. And in Unix land, it's make directory -P for preserve and the directory name. So these things are system dependent variables that I need to set. So I'm trying to make it as generic and as cross platform as possible. So here, if this is checking if package config came with a yes or no. So if it's a yes, we're going to use package config to add it to our C flags, these things. So our C flag up here has this std C++20, and then it's going to add in the output of, it's going to add in this C flag base. It's going to add to what you already there because we have a plus equals here. This is a Makefile function to run this command as a shell. And this command is going to output what we've already seen. This. So it's going to put this here. So it's going to be whatever this is. And then on top of that, all of this for us. So this is just populating the, adding to the C flags and the LD lib base, the outputs of the package config. And I'm right here, I'm using image, TTF, and mixer, and the normal SDL. Okay. But if it's not installed, if package config wasn't installed, we can't do this at all. So the make is going to fail. It's going to stop, and it's going to print this message like you need to install package config. So basically, this Makefile requires package config. And this is just setting up now. We have this cflags base that we've modified here, and we've set up here. We have this. So I'm just saying, hey, this is the one I want to use. So I'm just changing the name of it basically, but I'm also allowing you to override this from the command line. If you wanted to use your own stuff and you're saying, hey, just let me make it with my own thing. But it's going to say, hey, this base one is the one I want to use. And this LD libs base one is the one I want to use. So that's going to be what's going to be used by default. These are going to be populated with whatever these were, which is going to be this added on to what was up here, which is this one right here and this one right here that's empty. Okay, so that's kind of setting all these variables. I hope that all that makes sense with the variables and with the functions. Again, this shell is a Makefile function. This is the actual shell command that you can put into the shell. To this point, these are all variables, okay? So when we get down to here, this is a rule. So a rule is a target and any prerequisites, and then a command. So the target is the build directory. The build directory is this dot build right here. And so if I have anything that requires this as a prerequisite, says, hey, I need this dot build directory, this is the rule to make it. So this is the dot build directory. If anything required that, it's going to say make directory. So what is the make directory? Well, it was set differently for Windows and for Unix systems, but it's going to be this for my system, which is make directory -p and whatever the build directory is, which is the dot build. So this is a rule right here. This is the target. Over here, if there was anything, would be prerequisites, and down here is the command to run. Okay, so if anything requires this build directory, this is the command that's making the build directory. So that's the rule, target, command. Down here, here's another rule right here. Okay, this one's a little bit spicier, I guess. Basically, any time that we're building anything that is one of those O files, say we were building this flake O file, right? It wouldn't be in this top level directory, it'd be in the dot build. If that was one of the things, if that was a prerequisite for something, if one of my targets said, hey, your prerequisite is this .o file. So let's explain the prerequisite right here. This is a prerequisite. This is a target that has a wildcard in it. This is a prerequisite that has a wildcard in it too. And this is another prerequisite. This one is a order only prerequisite, something like that. Order, I forget the name of it. Order only or something. But anyway, what's happening here is this is a bit strange because it has a wild card here. But imagine some other thing is telling me, some other thing says I need .build flake.o. I need this. Something needs this. Like if it was up here. Let's just say for a minute it was up here. This was a prerequisite and it was down below here, whatever. Forget about the ordering. But this guy right here is a prerequisite. I need this. And we could do it with these variable names, right? We could put this right here. It doesn't matter. So we do this, right? This is the prerequisite. And here's our build. And our build says, well, for anything that's this and has any name in it and then .o, that's what this wildcard is, that this target is fine. That's the target that's going to be run for this. This is kind of a pattern matching wildcard thing. So if this is my prerequisite, this target says, I know how to do that. And that % is flake. So my prerequisite to build this, the thing I need before I can build this, is to make sure I have something that's in the source directory / that % is flake, just like it was here. So I need flake.cpp. Now this is checking to see if this file exists in the source directory. So it's going to go up here and it's going to say, hey, src, because that's what this equates to, assuming we haven't overridden it. Does flake cpp exist? Yes. Okay. That prerequisite has been satisfied. Now we have another prerequisite, and this is build directory. If this hasn't been built yet, this thing's going to run. Now, I'm kind of goofing around here, adding this prerequisite because there isn't one here. But this says, hey, if this isn't done, I need to do it. If it's already been done, it won't do it again. But if it hasn't been done, it's going to do that thing. It's going to make sure the build directory exists because this is going to be put into that build directory. So this says, hey, I need to build a flake.o file, and it needs to be put in the build directory. I have a prerequisite. Does the flake.cpp file exist? Does the build directory exist? Also, this one right here on this side of the these are prerequisites, and these are order only prerequisites. So order only prerequisite, it doesn't care if anything in this directory has changed. If anything about the directory has changed, it doesn't care as long as it exists. This one right here, it does care. If this CPP file has changed since the last time we compiled it, it's going to recompile it. So if this CPP file exists, and this O file exists, it's going to be skipped. The Makefile is going to say, you know what? I don't need to build this O file, this flake.o file, because I already have a flake.o file. And the flake.cpp file is the exact same timestamp as it was the last time. It has not been modified. It checks timestamps. So if it has not been modified, it just won't, it'll finish and it will never run the command down here because it doesn't need to. So it's doing it smartly. It's saying, make sure this exists. If this already exists and this has not changed since last time, I'm done. But if this doesn't exist or this doesn't exist, make them. You can't make this because it's a file, so this will fail. But if this O file does not exist, it's going to build it. And if this O file does exist, but the CPP has changed since last time, it's going to build it. And it's going to build it with this command right here. And this command is cxx is G++. So G++, and then we got the flags, which is minus std equals C++20 and any other flags on top of that. And then we have these two that I'm going to talk about in a second here. And then this is for the source file. This is to build an object file. So it says I'm using a source file. Okay. And what's the name of the source file? Well, this right here is an internal kind of variable name for Makefile. And this one says the first prerequisite. Okay. So the first prerequisite is this right here, this CPP file. So the name of this, that with source and everything, source /flake.cpp is what's going to be right here. This is going to be evaluated to what this is right here. So whatever this is right here is what this is. So if you see a $sign and this, I'm not sure, Pac-Man to the right, eating to the right, this one equates to first prerequisite. You could have multiple prerequisites, and I'm not talking about anything after this one. I'm talking about anything over here. I could have more things here. I could have 5 things, 10 things here. It's going to take only the first one. That's what this equals. So it says, hey, run G++ with your C++20 flags. This is a source file. The source file is called src/flake.cpp. The output file is going to be called, so this .o is output file for G++. And right here, this is the second Makefile specific variable name. A $sign and an @ symbol stands for this right here, whatever this is. So this is .build/flake.o. So this is source flake.c. So it's saying the source file is source.flake.c. The output file is going to be .build flake.o, the thing I'm building. These two are different. I'm going to swing back around to them in a second here. So this is my G++ to build one object file. Yeah. And here we have, so this is a rule here. We have a target, we have a prerequisite, and we have it just needs to exist. If it has changed, it's not going to affect the output. If this changes, it affects the output. If this is a directory, if something new is in the directory or something changes, it doesn't affect it. It's but it's also a prerequisite, but it's different. Okay, so but anyway, this is a rule, target, prerequisite, command. Here again is a rule. So this rule says make target. Target is yellow snow, right? That's the target we're making. And the prerequisite is this is going to equate to all the objects. So this is going to be a list of all the object files. Every one of these CPP files, but as an object file. So what's going to happen when it hits this, it's going to run this over and over again for each object file, right? So now it's going to have all the object files, right? And now we have a new strange variable thing. So this one is first prerequisite, which is this guy. This one is the target, which is this guy. This one right here is also prerequisite, but it's not first prerequisite, it's all prerequisites. So this thing is going to build a whole bunch of object files. It's going to build flake.o, fps.o, game.o, and initial SDL.o, main.o, player.o, all of those, right? It's going to create all of those. So what this is doing is taking all those object files and building the final binary. So we're doing G++, all object files, then we go .o for the output. And here we've seen this before. This is the target. And I don't mean target as in this is called target. I mean, this side of the rule is the target. This is going to be whatever this equates to, which is yellow snow. So it's saying G++, take all those object files, output yellow snow with the linker, the libs right here, which is whatever this is, which is up here, it is nothing. And then down here, it is the output of this, which gives all of our -L SDL2, -L SDL2 underscore image, all of those. And that creates the actual binary. So what happens here is if you call this guy, if I'm trying to build yellow snow, it says I can't do that. First, I have these prerequisites. I need to build these objects. It's going to go up here. It's going to go through all of the different objects that this expands to. It's going to run this on each of them. But each time it's going to say, I need to make sure C++ exists. If I have an object file and this hasn't been changed, I'm not even going to build it. But if I don't have an object file or C++ has been changed, I'm going to rebuild that object file. Also, build directory needs to exist. But if it doesn't, it's going to go up here, build the build directory. So you kind of see that this is using this. Okay. So we have these other things. So what's great about this whole system here is it only builds if I've changed the C file. Every time I change the C file, it will only rebuild. And I'll show you this real quick. Let's see. Okay, so I'm just going to build it real quick. So I have a build of it. So I've built it, right? Now, if I go to build it again, the same command. Oh, this is the output of that info thing. So you can ignore this. But it's basically saying, make is saying, hey, there's nothing to be done for lease. I'm already built. Cool. So it's not going to build it again. But what if we go in here to say game, right? And we just put another space here. Okay. I'll put a space here because the formatter deleted the other space. Okay. So we put a space here. So technically this file has changed. So will it compile just game.cpp or will it compile all of it? So right here, let me pull it up. What was it building? The very first thing it's building here is, yeah, it's building this one, the game, the file that I changed. So this is all this. This would be terrible if you had to write this in. See, there's my G++ command. Here's my std20. And then here's all those include things that are done by package config. This is all the include stuff, all the way to, I think, here. This is from package config. These are my, since I did release, this is my strict. All the way to here is my strict. And now since I'm doing release, here's my release flags. Release flags. And these two are added in separately. You know, this is the end of the build command. This one, the C, the output of the, it's using this, the source CPP and the output of the O file. So you kind of see that whole thing that I was talking about. And then when it has built this one object file, it needs to repackage up relink the final binary. So it's going to take all these O files. It didn't rebuild Flake or any of these other, it only rebuild game, but it's going to take them all again, and it's going to rebuild this binary right here, yellow snow, with these right here, these library that it's linked. That's cool, but that works for the C++ files I changed. But what if I change a header file? So before I had this bit right here and this bit right here that we're going to talk about right now, before I had these, if I were to change a header file, the C++ file that it goes with that header file would be recompiled. But this is a huge problem because I have header files that actually are required by more C++ files than just their namesake. So like main is included into every single one of these CPP files. So what would happen is if I change something in main and it recompiled, it would recompile main CPP, but it wouldn't recompile anything else. And these other files may have been dependent on the thing I changed. And so then the game would crash or wouldn't run right. And I'd have to do a make clean and then rebuild everything. So we need some way of making sure that if the header files change, that whatever is dependent on that header file also needs to be recompiled. And that's where this comes in. So we can use GCC and we can make it output dependencies. And it'll go through and it'll actually output dependencies for each of the source files. So when it's going through these CPP files, it's going to create a .d dependency file. What happens down here is this, it basically makes a dependency list and phony builds. We're going to talk about phony builds in a second here, but it kind of makes these dependency list of what is dependent on what, and then it adds it to the Makefile. So we don't see it, but it's going to add it to it. So if it says, hey, your game.cpp is dependent on game.h, but it's also dependent on main.h, it's going to add that as a dependency. So what happens is if game.h changes, it's going to recompile game.cpp. But if main.h changes, it's going to recompile game.cpp as well. So that's what this is doing here. This up here, we have created this dependencies right here. These from the objects. And down here, where is it? We are including these. So this is telling the Makefile, and we're going to talk about the phony targets in a second, but it's going to make a bunch of phony targets for building things if they need to be built. And so then when you trigger whatever build that you want, it's going to not only look at the dependency that you have here, it's going to also look at GCC, or the Makefile will also look at the dependency that the .d files have created. So the .d files, like I said, it'll have like flake.cpp, depends on flake.h, but also depends on main.h. And so it's going to check the timestamp of flake.h and main.h and see if any one of those were changed since the last time you compiled. And if they have changed, it's going to recompile that one, even if it was already compiled. So it's saying something has changed in it. So that is what's happening here. This is kind of like appending to the Makefile more phony targets, basically, as a dependency list. So let's talk about the phony targets. So these are rules here, and these are the targets right here. And this whole rule here is target prerequisite, so on and so forth. So you can have phony targets. And what phony targets are is they are not actually building something. Like the target name is not actually. So right here, this target here is actually the build directory. This target right here is actually an O file being built. This target right here is actually the binary here. This phony target all isn't anything. So here's one of the target, the phony targets here. Here's a rule. So if all gets called, it's just the prerequisite is target, which is up here. So it's going to build this as a prerequisite to all. So all is actually nothing, but its prerequisite is building the target. So if I were to go make all, it would just build the target. Okay. And then so I could say release just does all. So that's just doing this one right here. But what it allows me to do is I can change right here when I do this. When it sees this, this is not a rule. This is instead for when release is called, it's going to set this cflags variable to this. So remember, cflags variable was set to here. This base is going to override that. And so say, nope, I'm setting you now to the base flags, but also the strict flags and the release flags. And I'm taking the LD libs and I'm setting it to the base libs and the release libs, because some of the release ones some of these are linked together. Sometimes when you add some flags, you need to add also a linker for them too. So this allows me to change what the flags were and what the libraries that I'm going to link against, what they are, and then just tell it to build the normal target, which is up here. It's just building the normal target, but I have changed what this variable is and this variable. So I've done the exact same thing with debug. It's again, here is the phony target right here. This is me changing the variables if this phony target gets called, and then it just runs all. So all just builds, and it would build with just the generic, this one right here, which is just this up here and the outputs of these two, and that's just the generic one. So anytime the target is built or all is built, or you just call make, that's what happens. But if I do make release, it changes it. So it's building it differently. It's putting in the more strict flags or the more optimized flags. Well, the more strict no matter what, but it's going to put the debug flags or the optimized flags. But I can also have clean as a phony target. So if I say make clean, it's going to run clean, and clean is set depending on the operating system. So clean up here is remove the target, remove the build directory. And for Windows, it's delete forward F the target. And if the build directory exists, delete it or remove it, however that happens in Windows. So this allows me to make, so I can say make clean. And I can also say make run. And we've seen this before. Remember $ and Pac-Man moving to the right is equal to the first prerequisite. So run has a prerequisite, which is target. So run says, hey, make target first. Make sure we do this. If it's already made, we don't need to make it again. But if it needs to be made it. It's a prerequisite. But then also the same name, whatever this target evaluated to, is actually here. So forward dot, that it just means forward dot yellow snow. So it's going to say, hey, make yellow snow and then run yellow snow. And rebuild is just adding two phonies together, just saying clean. It runs this clean, and then it runs all, which is just this one. So you can kind of stack these. I can say make clean run. Run will automatically build it if it needs to. I could say make clean release run, or make clean run, or, I can use these differently. So these are phony targets. So I hope all of that made sense. Everything that I said here, that is a lot of information, I guess. And I didn't get into these. These are just strict. You can look these up. But I just want to explain how this works. So just know when you see wildcard, this is a function for this. Append is also a function. That's a makefile function. Not directory is also a makefile function. This info, which I'm going to remove right now, that was giving me that output earlier, is a Makefile function. Shell, like you could do backticks here instead of shell, but it's not as portable. It works in Linux maybe, but not other systems. So this should be more universal. This is using the make specific function that says I need to call a shell command. This one is an immediate mode. This colon equals is an immediate mode thing. It's evaluated now and stored. Whereas these other ones, they're actually evaluated whenever you see one of the dollar signs, this one, then it's going to go up and find the answer to it. Whereas this one here with the colon equals, this is found out right away and stored there, and that is there. I believe that's how that works. The question mark ones can be overwritten. Again, this is a rule. This is a target and a command. This is a rule here. We got a target, prerequisite, the other prerequisite that matters less. And this is the command down here. Here's another rule. We have the target, prerequisite, command. This is changing. This is adding things to the Makefile, adding more phony builds, and it's keeping timestamps of the dependencies. So that's what this is doing right here. This is creating those dependency files, and this one's doing it a little nicer. If you were to delete a header file, it wouldn't cause it to error. It would just not look for it anymore or something like that. So these two together is about making those .d files. Hope I explained everything to the best of my knowledge, but yeah, if you were doing this for another project, you would go up here and you would change the name to whatever you wanted the binary output to be. If you were targeting a different version of C, like you could change that to whatever you were targeting. I leave these alone. Yeah. If you had any specific, like say you were, let me just show you this real quick. So these are using package config, right? But what if you weren't using package config? What if I remove this real quick? I'm just doing this as an example, just because not everything is package config. Like in C, you might need to add the math library or something. You don't need to, I think in C++, but in C, I think you need to. You need to add the minus LM. So I'm going to go make clean because it's saying there's nothing to be done because it's already built. So, and then I'll just do release, and this should fail. This should fail when it gets to the linking because it's going to say, I don't know about this, all the things that are dealing with music. I don't know about them. Here it is. So it's like, it needs to link to the music library, the SDL underscore mixer. And it doesn't have it, and because I removed it from here. But let's just say, I'm just using this as an example, but let's just say it was something that you needed an added dependency for something that wasn't here. I don't think it needs to be up here on both of them. I don't think it matters for the C flags one, but it's the LD libs that it matters. So I could go up here to LD libs. Let's just say I had some random thing like in C, a math library. It would be like minus LM or something like that. But for this one, it's minus L SDL2 mixer, I believe. So that's what it would look like if I wasn't using package config. So it looks slightly different. This one is lowercase SDL, where it would up here would be uppercase SDL. It'd be uppercase, it's slightly different name. And you can get the output of it, but let's see if that compiles. So I cleaned it and rebuilt it. And you should be able to see the output of that clean too at the top here. See, it says remove minus F, minus FF, minus RF. Looks like I have an unneeded flag, minus F flag in there. But it's removing the build, then it's making the build directory, and then it starts compiling because I did the clean on it. But this time it completed successfully because look, the flag is right there because I put it in there. So if you don't use package config for all libraries that you would need to add, But I just use this as an example. Like I said, in I think in C, not C++, you need to do minus LM for the math library or something like that. So let's undo. And again, you can just see the output of this, but not everything uses package config. So you might need to do it the other way. So that's the output of these right here. But you can't do package config for like math. It doesn't work. You know, it's like what's math? But I could put it as like up here. Again, this is C++. I don't really know. It doesn't matter though, I don't think. Let's just see if it builds. I'm going to check out that F thing. That's a bit weird. Maybe the RM already has F baked into it. I'm not really sure. And yeah. So, and minus LM is there. So this is the C, not C++, but the C math library. I linked it even though I'm not actually using it. But anyway, yeah. So you could put other stuff here or up here that you needed. But I try to organize these, but this is just, you could put this, and this all on the same one. Although I don't want release and debug flags. These are different. These are opposites. One, the release when you're trying to optimize things and make things faster. The debug things, you don't want things to be faster or optimized. And you also want the debugging information and everything else. So they're vastly different. But this one, I do like to be quite strict. But then I found out when I borrowed my son's MacBook that some of the code I was writing wouldn't compile on his, so it would just fail out. It wouldn't even warn him because I turned warnings into errors. So one, I tried to make my code better, so it did run on the Mac correctly. A couple little things that that Clang was being more strict than G was being. And the other thing is I made it, if you just type make, it doesn't do the strict one. But if you do the release or the debug, then it does pull in the strict. So trying to make it work better for everybody. Hopefully that's explaining everything else. But let me just go over these once again. This right here, Pac-Man, that says first prerequisite. It does not count this one at all. That's first prerequisite. That's whatever this is, the very first one after the colon. That's what that is. This right here is whatever this target equates to. So it's whatever this evaluates to is this replaced here, as in the name, not the actual object file. You're saying, I want to build that object file. And right here, this is everything. So this thing right here expands out to this long list. So this is saying, I don't want the first one. I want all of it. And if I use this over here, it would still work. If I use the caret here, it would still work, I believe, with this, because it would take this thing and it doesn't take this thing, I believe. So it should still work. Let's try it. Let's go make clean. File not recognized, file format not recognized. Yeah, so yeah, maybe I was totally wrong on that. You can't use that caret up there. So anyway, the Pac-Man to the right is first prerequisite. So I'm just going to remove the this F, since it seems like this has an F baked into it. I'm just going to remove this and just take the F from here and check it on the make clean. Yeah, this RM has an F baked into it, so that means it's unneeded. That's cool. I'm just going to run it one last time and then clean this stuff up right here. Okay, and there's the snowman. Whoops, I want this. I want to, let's see. I'm just getting rid of those other things. I hope you enjoyed that, and I hope that was entertaining or you had fun. Thanks for watching, and I'll see you in the next one.